Hello, everybody, and welcome back to the 21st Talks podcast. My name is Colin Snell. Welcome to episode 12. Today, I got the chance to talk with Dr. Joyce Cooper from University of Washington's Mechanical Engineering Department. I'm accompanied by my co-host for this episode, John Hamann, who is a good friend of mine and also one of Dr. Cooper's master's students. Both of their work contributes to a field of engineering that is dedicated to overcoming obstacles facing our world. A lot of John's work contributes to rare earth extraction for more effective renewable energy systems, whereas Dr. Cooper's work is, there's a lot there to dive into. We talk about something called life cycle assessment, which is an engineering approach, which I think will really speak volumes to effective engineering for a future full of disasters that we're staring down. And a lot of times engineering is seen as one of the more technical areas of discussion within existential risk. Things like climate change, artificial intelligence, bioterrorism risks, all these things, this podcast has tried to tackle from really humanitarian focused perspectives. So I'm incredibly glad to have a conversation dedicated to just questions of engineering, and tying in those humanitarian connections that have already gotten a lot of time and a lot of focus on the podcast so far. Existential risk discussions are meant to be interdisciplinary, and I think today's episode really struck that balance in a way that makes me incredibly grateful both to Dr. Cooper, as well as to John, for coming on and sharing their time with me and their expertise. I am super psyched to have them on in the future, and I cannot wait to get this episode out to you guys. So without any further ado, my name is once again Colin Snell. Remember to like, rate, and subscribe on whatever platform you're listening to today's episode on. And here is episode 12 of the 21st Talks podcast, focused on engineering. All right, have a good one, guys. I'll see you guys next week. What are the forces, challenges, and ideas that define the 21st century? Conversations to understand the greatest figures and stories of today to create a better tomorrow. This is the 21st Talks podcast. Hi, everybody, and welcome to episode 12 of the 21st Talks podcast. Today is a very special episode, as always, with my co-host, which is I'm so excited for, John Hamann, who is, did I say your last name right, John?
No.
Oh, I screwed up again. Oh my gosh.
Hamann.
Nonetheless, John Hamann, who is a master's student of material science at UW in Seattle. And he's also a co-host for this week's episode with Professor Joyce Cooper, who is also who is a professor at UW. And we are going to have a fantastic conversation about sustainability, this really interesting field called LCA, and hopefully get to the bottom of some really important questions concerning sustainability and the future of material science. How are you doing today, Joyce?
I'm great. Thank you so much for having me.
I'm super excited. This is going to be really fun. So for the listeners who don't know, can you tell us about the work that you do? And especially, can you help us define what LCA actually is?
Sure. So I am a professor of mechanical engineering at the UW. Mm-hmm. I'm also adjunct in civil and environmental engineering. And a lot of my research focuses on the method called life cycle assessment. And most people have heard of it when it just focuses on climate change, when it's a carbon footprint. But life cycle assessment looks at a much broader range of impacts. It looks at water impacts, water pollution, water use, toxic impacts to health, ecosystem impacts. It can look at business impacts. It can look at societal impacts. But the important part of it is that it tries to go from cradle to cradle. So it tries to model everything from when we take things out of the ground and the environment to when we hopefully don't put them back into a landfill or put them into the air. Instead, we're continually creating a cycle, like life cycle assessment, so that we're creating a system that's more like a natural system.
Oh, so it's trying to twist or change the sense of production and sense of engineering into a more cohesive cyclical model, to help kind
Exactly.
of sustain. And that is not just, is it like when it comes to the sort of, not just the fields, but sort of the areas that contributes to its sustainability, it's, and like where are some of the other terms and ideas that are pretty heavily associated with LCA?
So there's design for environment. So
Okay.
that's when engineers and product designers and technology designers use models, life cycle assessment models, to understand the technologies that they're entering into systems. Um, there's industrial ecology, which really focuses on how industry creates um, like industrial ecosystems where we're partnering companies and industries together. So they're trading resources and creating systems that are not using so much resources and wasting so much.
Oh wow, that's really interesting because it's like applying models from I mean, a- as it is in the name, like ecology, and sort of like some of the best systems that we can look to in the world outside of us, but applying it to man-made structures and human-made structures, of both engineering and production. I feel like that's really interesting because that kind of twists a lot of what historically has been the case, where it's been this story of, well, we can, we can just pick ourselves up by our bootstraps as a species and produce in the way that we want to, and have these very non-nature inspired sort of systems of production and creation. So I'm glad that the field is starting to turn around back towards being inspired and taking lessons from some of the most robust systems in the world around us, which is natural systems. Can you tell us a little bit more about how you got into this?
So I was a mechanical engineering undergraduate, loved it. And I had a lot of experience working in manufacturing. So I worked for General Electric making steam turbines and other aspects of facilities management at a plant in Schenectady. Then I worked for General Motors and I made small motor cases to move windshield wipers back and forth and raise and lower Cadillac seats. Um, and then what I really wanted to do was bring the ideas of manufacturing into product design. So I got hired by a company to design um, communication systems for the Air Force. And it was really fun because I could design things that were easier or better to manufacture. So I thought, if you can consider manufacturing in design, then why can't you consider other things like protecting the environment? And so I decided that I wanted to go back to grad school, and I decided to get an environmental engineering degree. And I decided not to go to an engineering school like I did when I was an undergrad. Instead, I went to a university that had a much more deep wealth of different things that I could study. So I got to take classes in environmental policy and in business and in environmental law, in addition to working on my graduate work in engineering. And so when I wrote my application for graduate school, I essentially described what I'm doing now, which is so cool because it was so long ago. But I was continually building on what I had done before and trying to bring new ideas into it. And I think that my career continued that way, even through grad school and after grad school and when I joined the UW. So always kind of bring in technology design and considerations of the environment and society and how we can develop technologies that make society better.
Cool. I was wondering if you know of any good examples of like using design for environment and like how that's changed how a product has been manufactured.
Um, that's a really good question. It's not always successful, and unfortunately, a whole bunch of bad examples are coming in. All right, but so you had asked before, what were some related ideas to life cycle assessment. And another one that's sort of a partner method is called materials flow analysis. And materials flow analysis, instead of focusing on what a technology does, looks at how the globe uses something. So one of, I think, the greatest successes for materials flow analysis is when people started to look at lead. So back in the 70s, they kind of found that people had a lot of lead in their blood. And lead is a neurotoxin, so it's gonna make you stupid. I'm so sorry to use that phrase, but it's something that's going to affect your abilities to make good decisions and your health in general. So folks started to use materials flow analysis to see how people were getting exposed to so much lead, why we had so much lead in our blood. And the first thing that came up was the lead that we had added to gasoline to make it actually was to make the engines not knock. It was intended to make the cars run better. But if you put lead in the gasoline and then you burn the gasoline, you put the lead in the air and everybody breathes it in. So a lot of folks don't really know why we call gas unleaded, but it's because we needed to get the lead out of the gasoline. So that was great. But one of the true successes of this is that it felt like once they were on their way to getting the lead out of the gasoline, people were looking around saying, well, where else is the lead coming from? And how can we get rid of that too? So years ago, there was a television commercial where there was a child peeling paint off a windowsill and eating it. And I have to tell you, kids eat everything, and it's not a strange kid that eats everything. Kids just put things in their mouth.
Very normal, healthy children.
Absolutely.
Yeah.
So what they found is that we had added lead to paint because it makes it more durable. It makes it a lot more durable. And so it was in the house and people were getting exposed that way. If you put it on the outside of a house and it rains, the lead will go into the soil. And I'm so sorry, but the children are eating that too. And so people got lead out of paint. So that was awesome. So then they're looking around to see where else they can get rid of lead, and lead acid batteries. All right, so lead acid batteries, it's still kind of the same train of thought, but for lead acid batteries, the way that they kind of got it out of the system that comes close to us is to recycle them. And so a very, very, very high percentage of lead acid batteries, at least in the United States, are recycled. And so that's sort of keeping that lead out from exposing everything. But along come electric vehicles and power sources that need better battery technology. And so we're moving away from lead acid batteries and into the lithium ion kind of technology. But those are not recycled at this wild rate that we had attained for the lead acid batteries. So not an LCA example, but a materials flow example. But I love how people were like, okay, we're fixing this, and there's policy instruments that came into play during the whole story, and engineering that came into play, and economics. And we're still kind of with the new batteries, we're still kind of living the whole thing.
Wow, I had no idea that. It's like I've seen the products of the material flow assessment, and is it assessment or analysis? Sorry.
People call it materials flow analysis or substance flow analysis.
Wow, substance flow analysis is a pretty heady term. Nonetheless, I'm pretty this is incredible for me to hear, because of the fact that I've seen and I've experienced, I've seen the policy effects of these things. Didn't realize that it was from a cohesive sort of approach and sort of methodological analysis system that these insights were taken. I just assumed that it was a couple people who are really passionate about getting lead out of gasoline. Or I didn't realize that there was a approach here that helped guide us guided us to where we are now with our relation to lead, and hopefully other things as well that have also been taken out of our environment.
Well, and I don't know that it was this, concerted effort where everybody got together and read this materials flow analysis and said, okay, you do this and you do that and you do that. I wish things happened like that, because that would just be really demonstrating the power of good people. So maybe my question would be is if we can, how do we make more of that happen? How do we take science and put it into a form where people can gather around it and kind of figure out what needs to be done to make just giant things happen? I have not lately looked at the levels of lead in all of our bloods, but I'm thinking it's less than it was when we were burning it in gasoline.
I would hope so. Yeah, if it isn't, there's something else going on there.
Seriously.
Similar to the Roman lead pipes issue that led to widespread impotence and stupidity across the Roman elite classes.
Well, and yeah, and then there's Detroit, or the Flint, I think it was. So
yeah.
it's not perfect, and but there can be examples, and I think that's a good one of the power of people getting together and making things work.
Because I suppose it comes down to, because we have a question about sustainability and communicating it to decision makers. I assume through material flow assessment, it's a really powerful method to sort of substantiate the policy. But we can talk about that in just 1 second, because first, I really want to dive into this question that you just asked of how do we make science, essentially, it sounds like, how do we make science more intentional? How do we get more people involved, both in sort of ordering the priorities of where we can focus our research dollars, but also questions for engineers and questions for scientists and for additional research, into a way that kind of cohesively tries to tackle the largest issues facing our world today. Whether it was in the 60s, it was, the ones that were known, of course, are always different from the risks that are unknown. But it's there was a sustained effort against lead. Even if it wasn't a cohesive approach, there was still an approach there that was successful. And I think that one of the big things of existential risk, and coming from a field whose main goal is like, we have some really major issues we're facing down. How do we overcome these things? Like, actually overcome them. One of the things that we tend to run into is the fact that it's an academic field, and a lot of academics today, outside the engineering fields, of course, but a lot of formal academics is not about action, right? It's about abstractions, about theoretical approaches to things, right? And I think that there's a certain level of, and I especially feel this my home field of philosophy and home field of politics. The politics a little bit better here, though, is we've abstracted a lot of the useful ideas from history, from philosophy, from even some lessons from political philosophy, that people don't feel like they're accessible anymore. So I think a part of the question, how we make science more, not just accessible, but get more people involved in the sort of priority list and, cohesively working to tackle these really big scientific issues, is helping to find the right ideas that can inspire people to actually take up arms. Like, no, like, my thing is I'm gonna go into this very specific field, get a master's degree in this, something higher, and I'm gonna dedicate myself to this very specific problem. And in order to do that, you have to have methodological approaches. And it sounds like that's what a lot of LCA is.
That's very, very true. And it's benefited from here. So so John and I have worked together for 4 years now, I think.
Yeah, just about.
And he's, so if we can watch his eyes roll, one of the reasons that life cycle assessment is where it is today is because there's standards that dictate how you do it. And like an engineering standard says, that they all started out on being related to boilers, because we wanted boilers to be safe and not blow up. Sounds like a good idea. So they got all the experts together that knew about how to make safe boilers, and they made standards so that when people built boilers, they were following the experts' advice and not blowing up. All right, so life cycle assessment does that too. It has a standard method that's been discussed by experts, so that when people are working in life cycle assessment, it becomes something that follows what the experts think that is important to include. But I really think that we're at this crossroads. I think if you had asked this question about making science more accessible 10 years ago, what people would have said is, well, we just need a bunch of people that are interdisciplinary, like trained in how to bridge disciplines, and that'll work. And I don't know that that's been as successful to the end that you're describing of really bringing people together. But now I'm going to answer the question, unfortunately, like with I'm an academic and I've been working in life cycle assessment eyes, because like that is just truly who I am. So I also see us at this point where we have instant access to information, tons of information, good information and bad information. And as scientists or as engineers, there are methods that we can use to bring together large amounts of analysis on different topics and look at all of the results that people have gotten and present them in a way that allows people to make decisions based on the body of literature instead of a single study. And it's related to statistics, like basic statistics that some of us took in high school and some of us took in college. And basic statistics allow us to understand how to combine data that has different assumptions by it. But there's also, when we make models, there's models that are made in all different parts of the world, in all sorts of different universities, and we all bring our knowledge to the table. And so when I build a model of electric vehicles in the world, I might include different things than somebody from other universities at other parts of the world. So the trick is to use statistics and develop sort of a harmonization or a meta-analysis of models and data that people from all over the world that bring all of their great expertise in, so that we can sort of digest it in a way that says that, you know what, the answer's not 4, it's between 2 and 300. So trying to really bring the expertise of wonderful people into a way that we can bridge that gap. Now, so here we are, and everybody has all this access to information, but I don't know, John, if I've mentioned this in class lately, but if you think about sort of people's acceptance to uncertain information, it can be, and historically has not been all that great. People don't want to hear from me that the answer is between 2 and 300. They want to know it's 4. And I can't say that it's 4. But we're getting, I think as a people, we're getting more able to accept uncertainty. So here's my example for you. Ready? You ever watch the Weather Channel? I love the Weather Channel. But when you watch the Weather Channel and there's a hurricane that's about to hit Florida, the Weather Channel is not going to say, here's this one model and it's going to hit the east coast of Florida at exactly this point and everybody should evacuate. Instead, what they do is they say the US models are looking like it's going to hit in this range, and the European models, and they actually call them that, suggest that it's going to take a turn to the right and go off and hit North Carolina instead of Florida. So if people can watch the Weather Channel and say, okay, we've got all of this wonderful data that we're trying to digest, but we're really trying to figure out where we should evacuate people from. But I think we're getting there. And I think if we can take that skill, that general public skill of not needing to know that the answer's 4, that we can kind of bring in together all of the science and the data and get to a point where this instant access to information is really well digested by people. So before, we were going to just educate a bunch of people in interdisciplinary sciences. Now, you know what I want to do? We need to go back to K through 12 And we need to talk about information and data and making decisions under uncertainty. And we need to talk about implications of decisions and how they affect communities in different parts of the world and how they affect the climate. And so it's like my perfect view of, K through 12, it changes. And one of the big things when I was just starting at UW was that the folks that were coming through K through 12 had teamwork experience. Whereas when I was at school, we never worked in teams. I never worked in teams in 12, and I never worked in teams at university. But they made it so that it was part of the K through 12 experience, so that when people got to the University of Washington, I didn't have to teach people how to be respectful of people in teams. So I'm hopeful that we can kind of, like move forward K through 12, some of the aspects of understanding information and giving young people the ability to be able to assess and make decisions based on the information that's available.
Yeah,
is that too far?
No, that's one of the most, that was a fantastic thing to listen to just there. There's so many directions we can go with this. I think, sorry, what were you gonna say, John?
Yeah, I just one thing, and there's a lot to unpack there. When you were talking about kind of like, we'll just have everybody, do interdisciplinary science. One thing that I think was really impactful for me during my education was taking a folklore class and learning how people tell stories. And I think, if we want to make science more approachable, I think that is something that's kind of missing in science and engineering is kind of the story behind why we do the things we do, kind of the folklore of science. And I think, and we get a little bit of that, with in elementary school with Ben Franklin and Thomas Edison, but it's not really up to date with like leaded gas and all these things. So
Exploding boilers.
Wait, that's sorry.
No, so I love that. And I don't want to. There's also a lot of efforts that that take us to other places. So I had the opportunity to go. I was a Fulbright in Finland, and one of the most amazing parts of that, besides the ground source heat that I got to study, was understanding how they make decisions differently than us. And so when you were talking about your folklore experience, it was really me understanding people better, and sort of folklore being this missing thing that we don't have anymore, where we're really understanding people and history and how it is bringing us to where we are.
I suppose one of the things that I have realized, this was one of the things that I think when I was really young and I had the dreams to become an astronaut, and going through that phase of like getting really into like cosmology and like Neil deGrasse Tyson's work and thinking about space and getting really involved in climate change ideas. One of the things that always kind of, I guess, turned me off of going to STEM specifically was just how involved I am with narratives and with stories, right? And I think that it's absolutely something that is missing from a lot of STEM involvement. Because I know a lot of my friends who are currently undergrads at UW, for example, who are in these super intense engineering programs, a lot of them are in those fields because of like family expectations, and because they raised in situations where they were expected to go into a high paying career, and what that meant in their household was go get a biochemistry like degree, or like go figure out how to build really cool computers and make a lot of money for that. So there's this question of passion, pragmatism within our economic system, education, and sort of what education primes people for. But I think at the root of it, there's a human experience here that a lot of STEM education has been neglecting. Because if STEM is about, and we've talked about this extensively in some of my science and technology courses at University of Puget Sound so far, you know, the scientific thinking about the world tries to take the individual and the subjective out of it, right? And it's incredibly advantageous. It's really, really useful to be able to understand a tree as a tree and not just because of your relation to a tree, right? And to understand like how the like the water distribution system works and how acorns grow and like all these really beautiful insights in the world, and it informs our ability to have utility over the world. But that utility over the world doesn't mean anything unless if we know who we are, right? So I think that there's this sort of it's not even really a backlash against conventional scientific ideas, but there is a much needed place, I feel, for the human to be the basis in which people explore scientific ideas through education and through all these other things. And I think we're onto something here by saying that it comes down to those stories that we're telling about people. Because I think the thing is science is a beautiful story. It is incredible if you just if like sitting down and just thinking about it. It is a wonderful, wonderful story of us as a species doing some really, really interesting and wonderful things that have ethical byproducts that are overall fantastic and have really, really great potential for where we're going in the future. But I also think that a lot of people don't get into it for that reason. And I think having more folks who are in it because they want to participate in that collective story that they can help write a chapter of, I think that is a very essential aspect of this scientific education question. What do you guys think?
To me, it's this. All right, and so professor, but parent. So to me, it's sort of having a tool that you're passionate about, and then being able to bring it out into the larger good. I don't know that I'm doing a great job in answering your question.
No, this is fascinating.
And it's you hit a nerve when you mentioned folks getting into STEM because it was expected in their family.
Yeah.
So my I'm an engineer. My husband's an engineer. And wait. And my daughter's a theater management major.
Yes.
You know what? As she should be, because that is truly what she's passionate about. And what she wants to do is use that kind of communication as a means to help communities recognize and deal with problems. So, I can talk about this for a while, but let's talk about rent and Dear Evan Hansen and how those communicate things that we need to think about, things that relate to our role in society, and to what's going on in society. So for me, I think the work that I've done is always paid. As a mechanical engineer, and as a woman in the 80s, I did not have trouble finding a job. So I definitely understand the interest in going into STEM because it can be a really a good profitable career.
For sure.
But when you get there, or when you get at a university like the University of Washington that has so much to offer, and folklore classes, and like see if you can use that experience and that time to take what you love about engineering and sort of place it into the context of other ways that you can contribute and you can be happy contributing. Universities should not all be STEM. When we look at the University of Washington and we look at what's making money and what's not, you know what? Engineering in the med school, that there's really, really important parts of the university that are in the red, that have no students and have tenured faculty. but as a community and as a state, we really need to maintain. I'm not saying that the folklore class, but we need to maintain folklore classes. We need to make them accessible to people in engineering so that when people are graduating from the University of Washington, they have this amazing, rich, and deep, they have their deep STEM knowledge, but also sort of this more information on the world and how to access more information about the world.
Yeah, and I think one of the things I jotted down earlier when we were speaking is specifically when you're talking about climate, like weather models, and how now there's this sort of different way of talking about these things to the general public, right? One of the things that I am deeply passionate about is just public communication, right? Public communication of philosophical ideas that I think can help us live and build a better world in the 21st century. This is a weird century. We have a lot of very unique obstacles, and it comes down to having conversations like this that will essentially change how we can approach things and overcome new problems. And I think what we're really talking about here is problem solution orientation, right? We talk about from the great aspect that you opened up about with your daughter, for example, was she is working within a problem solution framework, right? She's saying that there are problems and here's my specific means to communicate truths about these problems to have an impact. And whereas an engineer might go in a similar field, and a nicely sort of problem solution oriented engineer will go and say, here are these problems, and engineering is the mode through which I want to have this positive impact. But still, what it comes down to is identifying those problems. So I think a large aspect of communication, or excuse me, a large aspect of education has to be equipping people to have the right ideas that can help them identify problems and then stand up to the call to action to tackle them in whatever way that speaks to their passions, whether it's art, whether it's politics, whether it's philosophy, whether it's writing, whether it's engineering. It doesn't matter where it comes down to, but what it does come down to is the ability to identify those problems and have the confidence in yourself and have the right community to help you propel yourself towards taking action against those things. I think that is a big solution that we need going forward.
So what about Evergreen?
What about Evergreen?
So my understanding, and I please check, is that Evergreen's educational experience is far different than the pillars or silos that we have at the University of Washington that begs John to have to go find folklore class to integrate that into his studies. Instead, my understanding is that Evergreen has we're going to look at this issue across all departments, across, all colleges, and we're going to solve it by bringing, the people in arts and sciences together with the people in engineering, together with the people in public policy and law. You should get someone from Evergreen on here. I don't know. I only know people that have gone there. But it would be super interesting to find out if that sort of for them it's not new, but the re-envisioning of the silos at the University of Washington and at the more sort of the more traditional university structure.
Yeah, I think it would be absolutely essential, because I think that sort of the liberal arts method that I'm currently experiencing at my current university, it definitely needs a little bit more STEM involvement, I think, to be able to stay fully relevant. I think what liberal arts as a traditional sort of pedagogical approach is trying to do is useful. I think the current version of it, though, is failing to live up to the necessities of recognizing the power of science. So I think to channel my Hegel here, finding the right and the wrong and the wrong and the right here, and finding a new way to sort of approach education, for example, really takes finding what UW is doing right and what UW's model is doing wrong, and combining it with other schools that are doing something different. So I'll certainly keep having those conversations.
But there's also going to be people that thrive at Evergreen that don't thrive at UW.
For sure. Absolutely.
And so, yeah, no, I'm always a one size doesn't necessarily fit all kind of person.
100%.
Which LCA tries to be, by the way, but it's
not. Well, we were going to ask earlier, how does sustainability and questions within LCA, how does it affect decision makers in politics and specifically those in powerful positions, whether it's economically or sort of traditional politically?
I don't think LCA is alone in not doing a great job in communicating the results in a way that's useful for people that make decisions. I don't think that's just LCA. But so some of it has happened over time, whereas in eventually people, all right, so very odd to have a research field that I was working on when it was just a bunch of STEM people. And several years back, the person that was helping me with my groceries at the grocery store started to describe to me why reusable bags were better than plastic bags. And so to have a field get to a point where people are kind of thinking this way, I kind of get this, sort of puts it so that people are kind of going to ask for the information and ask for the perspective. But unfortunately, they're not always going to get the answers from the LCA community. And they shouldn't be, because they're models, and sometimes they're models of the future. But
which infamously are always super accurate, right?
You know,
it's super easy to model the future.
It's true. And yeah, no, and John knows that I use models of the future in class, but when I do it, I don't try to come up with them myself. I let the Department of Energy tell me what the future is doing.
That's awesome.
And then I immediately try to tell him that doesn't make it right either. But all right, so here, wait. So it kind of happened over time that people would start to be looking for this kind of study, this one that talked about taking resources out of the ground and hopefully not putting them back in the ground, and how much they're contributing to climate change or how much water they're using. So it wasn't like a one-way flow of information. It was like people are starting to ask for the information, and then people are starting to provide the information, and then you know, lo and behold, all this stuff happened. So within the last couple months, Microsoft and General Motors are coming out saying they're going to be carbon negative. Carbon negative? That's amazing. I went to the General Motors website to see what they were talking about. And they're talking about, this again requires more research, but my impression is that they're going electric vehicles. So they're going to make all electric vehicles. But you know, that same data that I just talked about from the DOE and the energy information folks, you know, the electric grid isn't going to be negative anytime soon. So I get a little confused on how that all works out. So I make fun, but I really don't want to make fun, because I want companies to come out and say, we're going to do this. And then I want the scientific community to say, okay, if you're going to do this, you got to think about some of how this is going to work. So, you know, I think there's room here. I think there's room for these giant companies to say, we want to make this work. And if we're going to make this work, do you want to hear what I'm about to say?
Yeah, this sounds interesting.
All right. So if they're going to make this work, then we need to like not be creating our supply chain based on, John knows, he can hopefully see where I'm going to go with this. So General Motors doesn't want its supply chain to be based on the best, most renewable energy possible. Instead, they want to make it the worst and go and create excess renewable energies in those communities and help rebuild those communities with education and community development, so that this giant company of General Motors that has so much reach throughout the globe can actually move us towards carbon negative. That's what So wouldn't that be cool? Wouldn't it be cool if, you know, instead of putting up a bunch of photovoltaics someplace in the United States, they went and used folklore stories and an understanding of culture to go and fix some of the places. And it, you know, as an American, I shouldn't be saying fix the other places, because it's not for me to say they're broken, but to see how we can enrich the lives of people throughout the world and sort of deal with the crisis that we've been a large part of creating. So how's that?
I think it's a great idea.
All right, let's do it.
It's going to be messy, but you know.
And you know, it won't happen instantaneously. But I don't know. It seems like, you know, there's info from science. There's a pull of information from decision makers, and there's access to information everywhere. So how do we make that better? How do we make it so that we're truly on the ground improving people's lives and communities, and we're not walking in and saying, you know, I know what's best for you. I know what your community needs, because that's not in that spirit of folklore. And how, to me, folklore is really making you understand why things happen. So why do things happen in different parts of the world in a different way than they happen in the United States? And it's not for us to say what's best for them, but there's also an opportunity to get them better access to clean water and nutritious food and education, if they, you know, want it in a way that they can bring resources to their community and raise their communities up.
There's two connected ideas here that I think 21st Talks is starting to see as a cornerstone of our entire goal and plan for change, right? It's the two ideas are solidarity, both within a political sense and within sort of like interpersonal sense. And the other connecting idea is this concept of mutual recognition, recognizing everyone's full humanness, whatever terminology you want to do. And there are things that politically we talk about, you know, that we do, right? Like the traditional like liberalism and neoliberalism is predicated off the concept that you're thinking of people as human beings and you're trying to maximize their power and stuff, right? But within the last 50 years, we've seen the limitations in neoliberalism, absolutely. But nonetheless, I think whatever politics of form and whatever approaches life form in the 21st century, I think the most effective ones will probably be predicated off the ability to have solidarity through common struggle between groups of people, and recognizing that other folks from other areas of the world, or even from within our own community, have their own approaches to things. And a big part of what we have to do is recognize what problems we're actually in the fight together for. And I think there's a couple, you know, existential philosophical ones, which is just like the struggle of existing as a person in a pretty indifferent universe and everything that comes with that. But there's also questions of existential risk, right? And I think that's one of the reasons why the field speaks to me so much, is these are threats that we're in the fight together for, no matter if we don't like each other, if we like each other, right? One of my favorite things to say about the field of existential risk is that I haven't met a single person in it who I don't like, but if I even found an arch nemesis in the field, if they got a promotion over me into a research position, I would still probably be happy, because it means that someone is still doing work. Even if I don't like them interpersonally, there's still a solidarity there between, you know, based off of a recognition of, you know, what they're trying to do. So I think a related question here for you is, what role do you think new sustainable technology plays in addressing the existential threat of climate change? Like where's this all going when it comes to these major threats, but especially climate change? Also, that question is courtesy of John. It was a very, very nicely written.
So wait, is this what technologies should we be deploying, or what's the essence of this question?
So I guess the essence of this question is like, you know, when we're thinking in that problem solution mindset, you know, engineers love to come up with something new to address a problem that might be the result of something that we did of that same process 10 years ago. And so, you know, when I think about technology and I think about you know, new technology and how it can address problems in sustainability, I think there's two sides of, you know, we want to develop new technologies to address the problems that we have, but I think the flip side of that is changing kind of sort of like the root cause of that initial problem without over engineering a like a new product or something.
All right, I'm going to try something. So let's talk about medicine, and let's talk about all of the wonderful work that folks have been doing in technology related to medicine. Um, but we're causing a lot of the problems in the first place that the medicine is needed for. So help me out here. So I don't know where to go from here. What like so when you were talking about solidarity,
Mm-hmm.
And I think about solidarity from a technology view,
Mm-hmm.
but I also think about it from a why we have government view.
Mm-hmm.
All right, so one of the reasons that I believe that we have government is to do things together that we can't do alone, and environmental protection is huge in that area. Um, the Nobody owns the environment, and if I pollute and the wind blows it to somebody else's yard, I don't suffer, but they do, and they have no recourse. And there's been wonderful things that have gone on, especially when you consider, for example, pollution that goes inter country,
Mm-hmm.
and how people start to deal with this kind of thing. So I think I'm having trouble putting together something for this, but I think technological solutions are really important. I think coming together and sort of figuring out, are we causing the problems ourselves, and deploying technology that makes sense in that case. But John, some of the other things that we've talked about in class has to do with market responses. So we've got my thoughts about how government has a role in making sure that we're protecting the common good. We're laying roads and we're fighting fires, and hopefully we're protecting the environment.
Not poisoning each other.
No. um,
At least not
so,
in the open. Maybe with some lead gasoline back, but
um, but some will argue and that markets take care of things. If getting sick becomes expensive enough, then maybe people will stop polluting.
mm-hmm.
I don't know. Doesn't it take a long time to get there? John, if the rare earth metals become expensive enough, are we, gonna switch to another technology, or are we gonna really try to get more rare earth metals out of the landfill? I don't know, and I don't know that I'm doing a great job in answering your question.
No, this is really fascinating because of the there right now one of the really major pieces in existential risk is it's actually an economist piece called the appallingly bad climate change science of neoclassical economics, and it's all about how the models through which economists use sort of like predict change within economic systems predicate off of this idea of supply and demand. Kind of is, at least my takeaway from it is the idea that it's kind of us as a group of people trying to do something, throwing our hands up to the wind and saying, well, this sort of force of supply and demand will dictate and kind of control where we go, and it's going to lead us in the right direction. It's a faith proposition essentially, right? Which is kind of funny to think about in terms of like a very secular world, and pretty secular fields. But nonetheless, I think that's one of my main concerns with this question of, can capitalistic systems actually deliver us a sustainable technology that we need to save, really have any sort of equitably survivable future, right? Because the fact is that if we rely on supply and demand, that means that profit is still the intention and desired goal there, not necessarily human fulfillment and like proliferation of like joy and happiness or whatever else is the metric by which we measure a good human life. And I think that is a terrifying prospect for me, in terms of like how our systems of creation are actually predicated off of this concept of supply and demand, just guiding us in the right direction, even though what it's really based off of is like things that can be kind of artificially constructed. And it's not really the full picture of how I think things actually change.
No, and I don't think what I'm about to say is the solution.
Okay.
But one of the first things that Biden's press secretary talked about, John, and I told you this when class started the day after, was considering the social cost of carbon. Is this something that you're familiar with?
No.
All right, so it's like a carbon tax, okay? And so it's really the basis of what you're saying is if we decide that there's a social good that we need to protect, then we can tax it. And lots of examples we can talk about, lotteries and schools and there's lots of, so carbon tax. The social cost of carbon originated from working, at least relevant to the United States, in about 2010, and they ran some models and had some uncertainty associated with what the answer was, but what they were trying to do was determine how much it would cost as the climate changed. People would have to move. Agriculture would have to move. People would get sick more often. There'd be more pandemics. Sorry. No, seriously. And so what they did was, not only did they tell the future, but they actually put dollar values on all of these things. And we could spend a really, really long time talking about how hard that is. And when someone does it, you need to be careful, because all of a sudden everybody's citing you, and everybody thinks that the cost of moving, this farm from here to here is this much. Okay. That all said, state of Washington requires that, I can't remember if it's construction consider the social cost of carbon for infrastructure. And I talked about it in class, John, and I can't remember, but there's a Washington state law that requires that people consider the social cost of carbon in their economic impact assessment. But the original work came from the US government during Obama. No, who was president in 2010?
Obama.
Yeah.
All right, during Obama. And it kind of went away, but they're going to do something with it again. So I'm not saying that this is the answer, but there's a process here. So they recognized that that there was this issue that was causing a social future situation that was not desirable or that needed to be managed. And they worked together with a whole bunch of people to come up with how to cost the cost of putting carbon dioxide into the air today and 2 years from now, and etc. And so these concepts are around. It's not the only way to answer it, but it kind of gets us into this intersection of markets and how you value things and how you can, there's a lot of people that believe in carbon taxes. And then there's folks that say, well, if we have a bunch of carbon taxes, it's just going to get passed on to the consumer. There's tons of conversations that we can have here. But hopefully we're at a time in history where we can bring together scientists and engineers and economists and policymakers and do a bunch of meta-analysis and kind of see what some of our options are to move forward.
I think that's the thing that's so interesting about meta-analysis is it's like I don't know how to put this.
It's a way to bring science together.
Exactly.
Everybody's assumptions come on in. And I'm not going to leave out anybody's assumption because it's harebrained. I'm going to maybe mention that it's an outlier and why, but I'm not going to throw it away.
And I think that it's that sort of alignment of just all of this massive amount of data and assessments and just all these findings from all these different researchers, and as we were talking about earlier, kind of having a formalized approach to those things to help overcome the sort of I want to say like grammar and sort of differing like approaches between different departments and different university settings and all of that, but trying to overcome all of those to have this sort of centralized database of just all of these findings. I think it definitely helps to inform. I mean, it's the pooling of our collective knowledge of any given field, and that is that is a super exciting prospect for me.
And that's actually some of the basis of how Microsoft is intending to use artificial intelligence to combat climate change. And there's folks locally that you can talk to about
Wow.
that. And I don't understand it completely. It's on my list of things to read. But I can send you the link to a video that they have about their goal of being, I think it's carbon neutral by 2030, and and they're going to overcome the carbon that they've historically emitted by 2050.
Oh, wow.
I think that's what it is. But I think they've really tried to think about this, getting information in a useful format to everybody. And finding ways that we can use it better and be more in this combined effort to educate us all and get us all comfortable with the answer is not 4, it's between 3 and 300 or 2 and 300, so that people are sort of understanding that a lot you want science to be objective and perfect, but it's biased by what you consider in your analysis. And so this bringing together of different perspectives can bring perfection to science. Sorry, that one just like came out like the bottom note on an email. Sorry.
John, are there any questions that are standing out to you right now to lead the discussion in the direction of? Because I'd be happy to hear any of those.
I guess one interesting kind of like movement right now that I've been kind of following is the right to repair legislation, and I think it's a very interesting kind of coming of age of like these products that are tied into proprietary software and companies that limit the lifespan of their products to sell more in the long run. And it's now people are becoming angry about it, and there are some strong movements to fight back.
No, I actually love that. I love all sorts of aspects of that. And one is the repair.org website with the map that shows Washington State as one of the adopters of regulations relating to right of repair. But to me, it's really interesting. And another thing that I don't know as much about as I'd love to, the legal aspects of, you're talking about obsolescence because of software, for example. But I think about when I bought my first car and I could change the oil and the windows went up and down with a crank that I could fix, and I could fix everything on my car. And computers that, when one, connector goes bad, I can take the thing apart and fix it and have my computer still laugh. So it's been a while since I've been able to do that kind of thing. And what happened to the entire industry of repair? There's still a shoe repair place in Ballard.
Oh, nice. There's a couple cobblers left
totally,
out there in the world.
That's it.
I thought that was just like an old Italian village thing that was like left over, a couple left in the world, but I'm glad to hear there's still some in Ballard.
Well, and watch, people don't wear watches anymore, so forget about that example. But all right, so if I want to sell more computers, I want both the software and the hardware to come become obsolete as fast as possible so I can sell more computers.
Yep.
Computers have a life of, oh my gosh, sometimes 2 years. And so all those rare earth materials, John, that you've been working so hard to find new sources for, we're just sticking them in landfills every 2 years. So one of the things that I think is super cool about repair.org is that I don't understand the legal aspects of it. I was imagining that it had to do with me losing my warranty on my computer by taking the cover off. So it is super interesting, but it really, to me, feels like it's been kind of coming for a while. And actually, you can't have this conversation without mentioning phones, so we should mention phones. I agree with you. And so do you know who repair.org is? Is it kind of a grassroots thing? And is it an example of what you were talking about before, of people that saw something and then put together an infrastructure to start managing it?
I don't know much about repair.org specifically. There's a YouTuber that I follow. I forget, I think it's Louis Rossman, and he's a MacBook repair guy. And he is like kind of on this crusade to advance right to repair in all these in states across the US. And a while ago, he was in Nebraska, and Nebraska is actually a really interesting state because we have a lot of farmers in Nebraska. And all these farmers have John Deere equipment. And they have to take their tractor to a certified dealer in order to get certain aspects of their tractor or combine or different pieces of their equipment repaired. And they like that, which prohibits them from going to like an independent repair person or doing it themselves. So what they're doing is that there are some like hackers who have cracked the software and have allowed these farmers to change things around or like modify them in different ways to make it work better. But yeah, it's, you kind of have to like break the rules a little bit to get what you want.
So, but I wonder if the farming community was just the perfect community for that, because when I did for the USDA, I did all of this LCA data, and one of the things that we were looking at was farm equipment. And so we were trying to model what the fleet of farm equipment looked like. And the thing is that there's like really old tractors and really old equipment because the farming community used to make their stuff last for a really long time. And so they were probably, outraged when they couldn't have a tractor for that was 30, 40 years old. So maybe it's that combination where this person sort of found a culture that was ready for no, we're not going to accept that this is going to start happening, and was also able to work with the folks that were having the problem. But yeah, check out repair.org. And it's a website that talks about the laws related to right to repair throughout the United States.
Cool.
This is, yeah, I'm gonna definitely check that out. This has not been on my radar at all. I know, John, I think we talked about the tractors and right to repair like a little bit a while back when we had that first fantastic discussion about like man's search for meaning and all the fun stuff that was kind of the foundation of our friendship. But yeah, I'm super stoked to get into this. I have like several pages of notes at this point on my pad. There's just so many directions to take. I do want to be mindful of time though for you, Joyce, as well as for John. Are you guys okay on time to talk for another like 15 minutes, or should we cut it and move to the end closing questions now?
15 minutes is good.
Perfect.
But yeah, let's yeah, that sounds good.
This conversation is incredibly enjoyable. So we'll certainly have to do it again at some point. But Okay, let's see. What direction can we take for the next like 10 minutes before 5 minutes of closing questions? Um, oh, let's talk about stakeholders. Yeah, let's talk about stakeholders a little bit. I don't even know how to formulate a question about stakeholders at this point. John, do you want to
Sure.
jump in some pertinent stakeholder stuff to LCA and or material flow assessment stuff?
Yeah. So if I'm an engineer and I want to like make products that last longer, so I'm going to incorporate repair into my design for environment. I'm going to design my products to be um, repairable, right? Um, and how am I going to have an organization or a company that lasts on or that lasts, you know, that is kind of like durable, not durable, that's kind of that's the wrong word, but like is sustainable, like from an economic standpoint, like how
Yeah.
who's going to pay me to make a product that lasts for 50 years?
So some of the mechanical engineering design textbooks tried to to push this along. In if you remember when we talked about modularity, so modularity has a purpose in being able to remanufacture or repair something, but it also allows on the profitable side a company to be able to offer variants of a product. So I can have I can have cool iPhone 1 and cool iPhone 2 that has a little bit more features, but a lot of the same components that are used to make it. But it's like it doesn't like if you go and you work for a company, they want to sell more phones. So it really didn't take. But there's another aspect of it that bothers me. We need to collect and understand better data on reliability and what's making things fail. But that would essentially mean that we cared and we wanted the products to not be thrown away after 2 years. When I was teaching reliability in class, the mathematics are so much fun, but there's no data available like there should be. You should be able to go on the web and you should be able to say that this type of component fails at this rate, based on the mean time for failure and what's going to fail early and what's going to fail late. The only industry that really keeps that kind of information is the medical device industry. Because the FDA makes them, and in part it's related to safety issues with medical devices.
Yeah, you want to know how many how many years your pacemaker is going to last.
Exactly.
That's not, you don't want to have to get a new one every 2 years.
Exactly. So there's like an easier sell on that they can relate something to safety. But how do I make that argument for, the phone or the computer that I want somebody to buy? And for people my age, one of the things that immediately comes to mind, and it is also dealt with on the repair.org website, is appliances. When I bought my first washing machine, it lasted for like 12 years, and now you buy them and they last 5-6 years.
And they're designed to fail quicker now, is what it sounds like, as a completely purposeful thing.
Right, so that I'll go and buy another washing machine.
Yeah.
I don't have a good answer for you.
But I think, oh, sorry.
No, I just think there's such a possibility for really good data and really responses to all of this. We know how to do this. No one wants us to do this.
Why? So is the limitation like a financial thing? Is it that like researchers can't find the financial backing to spend time doing this? Is it like a getting more people on board? Is it a storytelling thing? Do not enough people realize this is a problem? Like, where's the locus of this problem? The lack of data, I mean.
We need to find a way to make it to make it pay. And I don't want to have to do things because they pay, but
Yeah.
that's why I'm an academic and not a CEO.
I think that's I think that's one of the limitations and again, that's the supply and demand issue where we throw our hands in the air and just expect the invisible hand or whatever to guide us towards like human potential. It only works so far, but it doesn't work when it comes to our economic system has a lot of blind spots. People are starting to become more aware of that when it comes to both like the ideological reaction to it, as well as sort of the people who are even like involved in it, right? But this is a major one. This is a major blind spot.
All right. So here, let's like move to now and
okay.
stay away from 12-year-old washing machines for a second. What about
terrible time to say that this actual podcast is brought to you by washing machines. That's a sponsor for today's episode.
What about metal straws?
Oh my God.
Okay. What happened, and you probably know better than I, because I a number of classes I start that the students all know way more about social media and the power of social media than I do at all. So it was a different industry, though, that sells reusable straws because they're metal, right? And they come with a little cleaner, which I think is key, versus the plastic straws. Okay, so like a plastic straw manufacturer is not going to retool instantly to sell either compostable or metal straws. They could do it, but it would be a big change. For sure. So the demand for that, was it TikTok or like what? Where did that happen?
I really think it was social media. Yeah, it was definitely social media. It was people. Yeah, so that means that there was a power through social media to make a change. I mean, again, it rubs me the wrong way a little bit because it's like, oh yeah, we could save like some turtles. Don't get me wrong, I'm not a turtle hater. No. I think we should definitely switch to metal straws. Much better. Okay. But also climate change.
All right. Like... So what your point is that couldn't we have picked something more important than straws? But it may have been the microplastic folks that were, and I like the microplastic folks because they're because they're doing a lot of what you were saying. They're joining together with a whole bunch of different people, and they're communicating what's going on. And our department just hired one person at least that is focusing on the movement of microplastics in the ocean. No, how cool is that?
That's really cool. Yeah.
And a year ago, did I know that there are 5 rivers in the world that have all of the microplastic in it? Of course I did not. So all right, so gotta love the straw thing, but how do you make that so that it's not straws, that it's really a problem that's going to have a much bigger something.
And I think the real question there is, what was the straw that broke the camel's back in relation to the straws that broke the... Yeah.
I also want to bring up a point about the microplastics. So my understanding is that we have so many microplastics because we're washing our polyester textiles that we made from our recycled plastic bottles.
Yes. All right. So why do clothes wear out? It's not because we wear them too much. It's because we wash and dry them. Oh no, I agree.
Wow.
So it becomes this wonderful ocean model, right? Because how is it getting from... All right, so from my house, it's going to the Discovery Park wastewater treatment plant, out to the Sound, and then out into the water. But no, I completely agree. But aren't most of the plastics related to the computer recycling and the other things that have been going on in different... I don't know.
I mean, I think when it comes to the really... I don't know, like I was thinking earlier, like potentially e-waste, like taxes as like a way to sort of increase, because we were talking about the Biden administration's approach to like taxing for social good. And in the sense of what was the specific term? Social cost, the social cost of carbon. That sort of viewpoint, I think, can be applied to things like waste in other directions apart from just carbon. I mean, historically they have, of course, right? But especially for microplastics, and especially for, I think, e-waste, like the, where it's like cobalt gets into the dirt and stuff and is not exactly good.
No, it does. But you have to remember that we live in Seattle and the rest of the world is not Seattle. So
yeah, exactly.
I can't remember 2009, we started taking people's computers, printers, televisions for free in the state of Washington. And of course, the story goes on, as John knows. But that part where we made it through the state of Washington to start the system was a good start. It's just that there are some hiccups along the way. So yeah, I don't know. I don't know. But you have to make the straw work for more issues.
Yeah, I think the straw strat is definitely going to be applicable for the rest of a bunch of other issues. I think we need to just get TikTok and YouTube on our side here. Those social media giants.
Well, that and what was the one where they're throwing ice water on top of people?
Oh yeah, the ASL.
ALS.
ALS. Okay, yeah, not the American Sign Language
Challenge. So no, but that sort of created a platform for how this is going to work by engaging famous people.
Yeah, it's using the desired clout of individuals as kind of a gateway into effective change for things. And I think that's, sorry.
No, it's the definition of influencer is what I was going to say. But again, I'm not on social media. So whenever I talk about it, I'm like, ooh, I should talk about it.
It's a fun area to talk about. Also terrifying at other times to discuss. I think we should, just for time reasons, we should move to the closing questions. So we have 2 closing questions. Actually, I scrapped that for 3. I missed one. But the first one is, and these can be rapid fire, or you can dive into these as much as you want to. But what advice would you give for a young person looking to learn more about the field, about your field specifically?
So this is another point where I'm talking from me.
For sure.
And I think engineering is a really good basis for how life cycle assessment evaluates technology, collects data for technology. But working with engineers and working with economists is needed to move things forward, which an hour ago is what I said hasn't really worked. So I love engineering and I see the role of engineering in this, but I also try to see the role of other fields as well. So I guess my advice is find the tool that you think is really interesting to work on, and the associated data, and then look for things to apply it to make a difference. But it seems like you can do that vice versa as well.
That's awesome. That's really, really lovely advice. John, would you like to ask the closing question that you wrote down?
Yeah, so given your experience working with sustainable technology, are you optimistic about the overall survival of our species?
Future, good or bad?
You were so kind as to send me questions to think about beforehand, and it really did help me sort of prepare some of my thoughts for this. That was the only question that I wrote after. I know that you. All right, so these days, I think for everybody, it is hard to be optimistic, and it's been a hard 4 years as a person who's worked for so long in climate change and in science. So it's been hard to be optimistic for really quite some time. So long term, I just have to say, and so then I want to think a little bit about the shorter term. which is somewhat why I was asking questions about gradations of existential thought. As far as in the long term, I don't know, because I can't. The future can look so different based on what we do in the short term.
Yeah.
And I want to be optimistic in the short term. I guess for the times that we do work together and try to address big problems. And actually talking to you has made me more optimistic. And even thinking about the metal straws, and if we could channel that process into bigger issues, then that honestly would make me optimistic.
We'll just have to accept a little bit of uncertainty.
It is. So for me, sustainability is really about the future. So it's to me, it's about you. It's about my daughter. And hoping that you can have wonderful and full lives. Not only thinking about how you're affecting the world, but sort of within the world that you're creating, and your family and the people that you care about. I don't know that I'm optimistic. I'm so sorry.
But I think the core lesson here is the fact that these sort of conversations are the things that help to inspire a sense of not just optimism, but a more realistic sense of realism. And I think that's one of the biggest foundations of 21st Talks and the project as a whole. Is every person who I've talked to in existential risk so far, none of them are fatalists. And they started off as fatalists, but the more they got involved in the field, the more they got involved with people who are working for solutions and trying to understand how we can overcome things that can, like, some of the existential risk people I've spoken with are working with like the CERN like particle accelerator, and there's a fear of like the Higgs boson being unstable and just like essentially like ripping the universe, like stuff like that, right? Like apocalyptic level stuff.
Yeah, no, I think it's gonna be a slower death than that. I
think so too. But the important thing there is our ability to struggle against that and fight the plight, regardless of if you getting your hands dirty, getting into the ring, regardless if you think you're going to win or not. We have to start thinking about our fight against climate change, artificial intelligence, and all these really major potential threats. We have to think of them not in terms of, will I be able to fix this, but in terms of, can I help it a little bit? Can I just do a little bit of good in the context of this really big thing? Because if we have enough people doing that, then we can overcome these things.
Well, and I've enjoyed speaking with you very much, but does that individual also get something by joining? Yes. And I'm doing my one little thing, which is hard to see the benefit of, but I mean, as a species, don't we need each other? And isn't that some of what's been really hard the last year?
Yeah, and I think that's one of the reasons why the concept of meaning orientation, which is another cornerstone of 21st Talks, and really is the basis for how I think we can get more people involved in fighting existential risks, is we have to show people that one of the most meaningful things anyone can do today is to participate in this collective story of what individuals and communities decide to do at the beginning of the 21st century to overcome the obstacles we're facing. And every person alive today in some way can contribute to that story. I think that is one of the most profoundly meaningful things that this project has taught me so far, and is the cornerstone of, I think, anything I go and do going forward, because that is true. So why not participate in that story?
Find the good in people and in yourself at the same time.
For sure. Thank you so much for this
conversation. It was really fun.
This was awesome. Yeah. But yeah, just thank you both. John, it was fantastic to have you on as a co-host. And Joyce, it was very lovely talking to you.
You as well.
But I hope you guys have a good rest of your day.
Thank you.
All right, bye-bye.